To solve and graph my compound inequality, I'm going to solve each of the inequalities individually. 2x minus 5 is less than or equal to negative 1 is a linear inequality, so I can solve this just as if it was an equation, but if I divide by a negative, I'll change the direction of the inequality. I'll start off by adding 5 to both sides. This will give 2x is less than or equal to 4. When I divide both sides by 2, I'll have x is less than or equal to 2. My second inequality, 2x minus 3, is greater than or equal to negative 11. That's also linear, so I'll add 3 to both sides. 2x must be greater than or equal to negative 8. Dividing both sides by 2, I'll have x is greater than or equal to negative 4. And these are connected with an OR. To start making my graph, I'm going to graph both of these independently, but on the same number line. My first inequality says that x has to be less than or equal to negative 2, to positive 2, excuse me. So here's 2. I need values to the left of 2, and since I have less than or equal to 2, I must include the endpoint 2. The second inequality says x has to be greater than or equal to negative 4. Negative 4 is over here. I want values that are bigger than negative 4. Those are to the right. And again, I have greater than or equal to a number, so I'm going to include the square bracket. And then because I have the connector OR, I need to find locations on the graph where I have one solution or the other or both. And that's everywhere. That's the entire number line. So if I were to graph this, I would just have to shade the entire number line. If I wanted to express the solution in interval notation, I would go all the way to the left forever to negative infinity. To the right, I can also go to infinity, and I use the parentheses. And this corresponds to the set of real numbers.